Aviation's outstanding record of achievement during World War II is now a proud chapter in our nation's history. The Naval Air Arm attained unprecedented stature as a decisive tactical weapon, fulfilling beyond all expectations the hope and promise which pioneer naval airmen had long foreseen. Much of this increased effectiveness came as a result of important new advances in the design and operation of carrier-based aircraft. During the previous 2 decades, the radial-type air-cooled engine had been developed and repeatedly improved to higher power and performance standards. In step with these advances in aircraft power came the perfection of practical monoplane design, adapted for the special requirements of carrier use. Improvement in speed and coordination of carrier operating techniques, so vital to naval aircraft, resulted in a high degree of military effectiveness. Added to this was the vast fund of combat experience, which together with a steady flow of further technical improvements, contributed to the superiority of these weapons. The pressure of war intensified research and development in every field which promised new and better weapons. Faced with performance limitations in propeller-driven aircraft, interest turned to jet propulsion as the logical development in the need for higher speed. To realize fully the potentialities of this new form of power, it was necessary to design and build an entirely new type airplane to conform to the limitations of carrier operation and yet take full advantage of the high speeds inherent in jet propulsion. The McDonnell Aircraft Corporation was asked by the Navy to build such an airplane. The result, the XFD-1, first all-jet-propelled airplane designed specifically for the Navy to meet the exacting requirements of the carrier-based fighter. Christened the Phantom, the small size and high speed of the XFD makes it as elusive as its namesake. In appearance, the Phantom is different from conventional Navy fighters. Slender and small, with a tapering nose and tail set high, its wings are square-tipped and straight. These wings house 2 turbojet engines, the embodiment of a new concept naval fighter design. Historically speaking, this airplane started back in 1941, when the Navy contracted for the development of the first American-designed turbojet engine. Constructed by Westinghouse, this Model 19A engine is the prototype for those used in the Phantom. By 1943, after exhaustive research and test proved, known as the 19B, its performance, still secret, gave promise of speeds heretofore unattainable. This Westinghouse unit of the axial flow type has 6 sets of compressor blades and 1 set of turbine blades. Despite its slimness, all the necessary engine accessories are contained on the engine. To take full advantage of this lightweight, high power, and compactness, McDonnell engineers set about designing an airplane necessarily unconventional. First, for wind tunnel testing, came a model wing section with features especially adapted for very high speed, combined with the good low-speed characteristics necessary in carrier flying. After a suitable wing had been chosen and tested, a slim fuselage was added to the propellers could be set in close to the fuselage. The intake ducts were built into the leading edge, thus maintaining the high aerodynamic efficiency of the wing. With the addition of landing gear, empennage, and pilot's canopy, along with refinements in design resulting from months of testing in low and high-speed wind tunnels, the external shape of the Phantom was complete. Strikingly slim and low, the Phantom is 37 feet long, 13 feet high, with a wingspan of 42 feet. Having no propellers which must clear the ground, the fuselage is only 30 inches off the deck. The tricycle landing gear, a new feature of naval aircraft, provides additional stability for carrier landings and keeps the hot gases from blasting down onto the deck. The turbine units, tight against the fuselage, lie close to the center line of the plane. when one engine is shut down during flight. Installed through the wing spars, all of their high-temperature combustion and exhaust action takes place aft of the rear spar. In this way, the wing is an NACA laminar flow type airfoil, and like the rest of the airplane, finished to extreme smoothness for greater speed. The engine units extend slightly forward and aft of the wing center section, and the cockpit is set well forward to ensure maximum visibility for the pilot. The empennage, with its large vertical and high horizontal surfaces, ensures clearance for the jet exhaust and maximum stability for maneuvering and high-speed flight. When the Phantom is compared with conventional shipboard fighters used during the war, the differences in its design and construction are apparent. The propeller-driven fighter, much larger than the jet plane, weighs about 12,000 pounds. The pilot's cockpit is to the rear, aft of the fuel, the wings, the engine, and the propeller. In the 9,000-pound Phantom, the pilot sits ahead of all equipment except the radio and guns. This provides an excellent field of vision, which is of vital importance in combat and adds greatly to the carrier pilot's efficiency. Each one of the Westinghouse engines used in the Phantom is less than half the size and weight of the double-Wasp radial engine, yet at maximum speed produces equivalent power. With smaller profile and the absence of complicated accessories, the jet engine permits better streamlining, greater simplicity of installation, and reduced fire hazard. Although the Phantom's weight is only 3/4 that of the conventional fighter, its two turbojet engines develop twice the power. At top speed, the fuel consumption in the two airplanes is roughly equal, but when operated at lower speeds, the Phantom is less economical. In armament, the two planes differ somewhat. In the conventional carrier plane, the gun installation is in the wings, whereas the Phantom concentrates all its firepower in the nose. For rapid arming and servicing, automobile hood-type doors give access to the gun compartment and radio equipment at workbench height. The cockpit of the high-powered propeller-driven plane has become increasingly elaborate and complex. Propeller governor, supercharger, oil cooler, intercooler, cowl flap, and mixture controls, all are necessary for operation. By contrast, in this all-jet airplane, a single throttle lever controls each engine. All equipment is powered electrically, and small switches replace the usual large hydraulic handles for landing gear, flaps, and other components. In flight, general cockpit procedures are much the same as with conventional airplanes. Engine starting requires auxiliary electrical power and is controlled automatically after the pilot throws a contact switch. The jet blast is luminous directly from the rear and for only a few seconds at startup. This flame disappears completely as engine speed increases. In ground operation, although the danger of the propellers has been removed, crew members must be careful of the jet exhaust blasting out of the tailpipes when the engines are running. At idling speeds, the blast from jet engines is no more hazardous than the slipstream from conventional propeller-driven planes. But at takeoff speed, it has sufficient power to be dangerous as far back as 50 feet. The danger, however, is due to the great velocity of the gases rather than high temperatures. In front of the Phantom, the jet inlets with their high suction are more to be avoided than the blast at the rear. Minor injury to personnel and severe damage to the engines can result should loose articles be drawn into the ducts. Typical of planes using tricycle landing gear, taxiing is excellent. Reported by experienced pilots as having superior ground handling characteristics, the Phantom is particularly well suited for its job aboard or ashore. With unobstructed vision and no torque, the pilot can guide the airplane accurately without the usual twisting and turning to see ahead. Steering is easily accomplished by brake action on either of the main wheels. Unlike reciprocating engines, these turbojets require almost no warm-up period, and the jet plane can taxi out and take off immediately after startup. Into position and ready with no time lost. A normal takeoff is made with the wing flaps down. When flying speed is reached, the Phantom, like all tricycle airplanes, is pulled off the ground. Jet aircraft climb best at speeds much higher than propeller-driven planes. On takeoff, it goes out low, picking up speed rather than pulling up immediately in a steep climb. Takeoff tests were conducted to determine the ability of the Phantom to operate within the limitations of a carrier deck. Each time, the plane was airborne within the distance marked off. The flight testing was observed from a Corsair, which paced the jet plane, and exhaustive data on performance characteristics was recorded. The absence of torque and the concentration of both weight and thrust close to the planned center line of the airplane make the Phantom easier to maneuver than most high-powered fighters. With low wing loading, it can turn tighter without the usual mushing or tendency toward high-speed stalls. Thus, the Phantom possesses a combination of speed and maneuverability not previously attained. Another feature new to fighter aircraft is the absence of engine-induced vibration. With only one moving part, the turbine compressor shaft, and with the entire engine installation placed aft of the pilot, a new quietness in flight is achieved. The installation of a belly tank provides sufficient fuel to extend the range of this service jet fighter to approximate that of the conventional carrier fighter. In the interest of greater range and increased safety over water, the Phantom is designed to cruise at normal speed on either engine alone. In emergencies, it can easily land aboard with only one engine operating. In the final approach, the pilot enjoys a wide field of vision, unobstructed by the bulk of an engine and propeller in the nose. With this increased visibility and tricycle gear, carrier landings are more easily accomplished. With flaps down, the plane makes a normal tail-low landing, characteristic of conventional fighters. The nose wheel can be held off very low speeds, or on carriers, until the arresting hook engages a wire. Exhaustive tests at its home field confirmed for the Phantom's designers and builders their belief in the airplane's ability to meet and exceed naval aviation requirements. Though its performance on land, under conditions approximating those of a carrier, were highly satisfactory, the final proof was yet to come. In July 1946, the Phantom was put aboard the fleet's newest aircraft carrier, the Franklin D. Roosevelt, for flight tests at sea under actual carrier conditions. This was to be the first time an all-jet airplane would operate from an American carrier, and the interest on board ran high. All hands gave the newcomer the once-over as it was rolled into position for the first takeoff. On the flight deck, the Phantom, with its electrically operated folding wings, seemed like any other carrier plane. But noticeably absent and welcome to crew members was the usual danger of spinning propellers. Although the Phantom had taken off many times within the length of a carrier deck, this was the first time it would be aided by the carrier's forward speed. Airborne in less than one-third the deck length, here was proof of the Phantom's sound design and the successful performance of its turbojet engine. Justification for the Navy's confidence in this new type aircraft. Following a normal steady approach with tail low and hook extended, this first landing, made by Lieutenant Commander James J. Davidson, was as routine as the many descents made onto large stationary fields. The tricycle gear provided added stability as the first carrier landing was accomplished. As with other Navy fighters, the Phantom is provided with the usual catapult hooks. And, should conditions warrant it, rocket assistance can be used for minimum takeoff runs. Repeated takeoffs followed, and each time the Phantom became airborne quickly, well within the short takeoff distance required in carrier flying. Interest centered on the Phantom's ability to take a wave off, an important factor in carrier operation. This maneuver was also tried, and the wave-off rate of climb exceeded expectations. In its never-ending search for better weapons for the fleet, the Navy may well regard the Phantom as representing the future, as war-proven conventional fighters represent significant achievements of the past. After 5 takeoffs and landings, the tests were successfully concluded, and the Phantom was flown back to the beach to take its place in the program of constant testing and research, which is the keynote of forward-looking naval aviation. Planes like these and the progressive spirit behind them, the continuous advancement of our naval air power is assured. We at McDonnell Aircraft Corporation, privileged first to explore the possibilities of jet propulsion adapted for carrier use, feel certain that the FD-1, the Phantom, represents the first of a group of airplanes, which with further acquaintance and use will earn the highest regard from their pilots and crews, and will mark another step forward in the development of naval air power.